Imagine a contest with no clear arena, the raw biological wiring behind every human thought against arrays of silicon, data centers, and code. Today, we ask a simple yet enormous question. Which is stronger, the human brain or artificial intelligence? To answer, we'll compare what each does best, what each cannot do, and what the future might hold if these two forms of intelligence collide. The human brain is a compact, massively parallel organ that achieves remarkable feats with astonishing energy efficiency. A working brain consumes roughly the power of a small light bulb, on the order of 10 to 20 watts, while performing perception, motor control, reasoning, and social intuition. This energetic efficiency and the brain's mixed analog/digital operations are part of why human cognition still outmatches machines in many real-world, ambiguous situations. Humans excel at contextual understanding. We can read intent from tone, infer hidden meaning from fragments, and apply moral judgment in complex social settings. Those are not just extras, they are central to how societies coordinate, create art, and make decisions under uncertainty. Artificial intelligence, by contrast, is built for scale, speed, and pattern extraction. Modern large models can iterate on millions of documents, spot statistical regularities invisible to humans, and perform tasks, translation, summarization, code generation, data analysis, faster than any individual human. On many standardized benchmarks, advanced models such as GPT-4 reach or even exceed human-level performance. Where AI shines is repetition and scope. It remembers massive corpora without fatigue, it optimizes at scale, and it can be distributed across thousands of chips to solve problems in parallel. But that power comes at a price: massive energy consumption, specialized hardware, and a brittle dependence on the data and objectives supplied by people. Importantly, intelligence in brains and intelligence in machines are computationally different. The brain uses a mixture of analog signaling, spikes, neuromodulation, and plastic wiring. AI models use matrix math on binary silicon. This difference explains why some tasks transfer poorly from one system to the other. Creativity, embodied experience, and certain forms of causal reasoning remain easier for humans. Raw pattern matching at scale remains easier for machines. Rather than asking who will win, a more useful question is, how can they complement each other? In medicine, AI can mine datasets to suggest diagnoses, while human clinicians integrate patient history, ethics, and nuance. In science, machines accelerate discovery. Humans set the questions and check the meaning. The most powerful systems emerging today are hybrid teams, human judgment guided and amplified by algorithmic scale. Stanford's AI Index and other analyses show productivity gains when humans and AI collaborate, not replace. But there are real risks. Fast, highly capable AI could widen economic gaps, shift power to organizations that control compute and data, and produce brittle systems that fail in unexpected ways. Leading thinkers and some governments warn of safety and governance challenges as systems grow more capable, problems that are technical, political, and moral all at once. My reading of the evidence: in narrow tasks, AI already exceeds most humans. In broad, embodied, socially embedded intelligence, the human brain remains superior, and does so with dramatically lower energy cost. The likely near-term future is not AI replaces the brain, but a reshaping of tasks. Machines take scale-heavy, data-heavy work. Humans focus on context, values, and oversight. So, who's stronger? The true answer is, it depends on the task and on the rules we set. Now I want to hear from you. Do you trust AI to make moral decisions? Should we limit development of systems that could outthink us in key areas? Or should we accelerate, trusting innovation to solve the risks? Write your view in the comments. The future will be decided by debate as much as by code.